Hello guys, welcome back into mathematical lesson whereby we will be continuing with this Euclidean geometry problems. So we will be doing this problem that is here right on the screen, question 9. So 9.1 says to us, complete the statement so that it is true. The statement that we are given, the portion of the statement that we are given, it says to us, the angle subtended by an arc of a circle is. This statement says to us, the angle, oh, what is happening with that? I don't want it to be this thick. I want to, yeah. So it says the angle subtended by an arc at the center of the circle. What do we know about this? So now, if you have the circle here, you have the center of the circle. Now here you have the angle subtended by this arc. This angle subtended by the arc that is at the center is 2 times the angle subtended by the arc at the circumference, right? So now, when completing that statement, we're going to say, let me erase this so that I have some space to write on. So we are going to say, the angle subtended by an arc at the center is 2 times the angle at the circumference of the circle. The angle at the center is 2 times the angle at the circumference. The angle at the center is 2 times the angle at the circumference. So yes, that is 9.1. Now going to 9.2, it says O is the center of this circle, and TNSPR are on the circumference, right? Yes. POS is 60 degrees. We can see here at the center. PS is equal to, this is PS is equal to NT here. Okay. Now let us quickly do our technique DRCPT, Dr. K. Tau. DRCPT. So the diameter, you will ask yourself if there's any diameter on the diagram here, but we can't see any diameter. We go for the radius, and we find that OP is the radius of this circle, and OS is the radius of this circle. Therefore, OP is equal to OS. Now, it forces a triangle POS to be an isosceles triangle because OP is equal to OS. Now, we can just say OPS is equal to PSO, which is this angle, reason being angles opposite equal sides, right? Now we go for C, a cyclic quad, but we don't have any cyclic quad in the diagram. P, we don't have parallel lines. T, we don't have any tangent in the diagram. Now, calculate the size of, but they didn't mention with reasons, but you need to put it in mind that always you need to calculate the size giving reasons of a angle PRS. PRS. So what are we going to do? Excuse me. Now, we go for P is there at the center, or I mean P is R is there at the circumference and O is there at the center because we want PRS, which is this angle at the circumference. So angle at the center is 2 times angle at the circumference. Therefore, the one that is on the circumference is half of the one that is on the center. Now I will say PRS is equals to 30 degrees. Why 30 degrees? Because angle at the center, angle at the center is 2 times angle at the circumference. Angle at the center, angle at the center is 2 times angle at the circumference. Angle at the circumference. Right, fine. Now let us go to the next question, 9.2.2. We are required to find the angle of NST. NST. So it's NST, which is this angle here. So what are we going to do? Remember, there is that theorem in grade 11 that says if I've got this triangle, I also have got this triangle such that this chord is equals to that chord. That angle will be equal to that angle. That angle that is opposite the chord and that angle that is opposite the chord. Those angles will be equal to each other if these chords are equal to each other. Now, let us come to the triangle PRS, and then there's a chord there, PS. We also go on a triangle TNS. There's a chord TN, and TN is equal to PS. That implies that the angle that is opposite PS will be equal to the angle that is opposite TN. Now, we will say NST here is equals to that angle PRS, right? And then they are both equals to 30 degrees. Why? Because equal chords, I don't know why this pen of mine is writing like that. So I'm saying equal chords subtends equal angles. Fine. Now we go to the next question. I hope this makes sense to everyone. Now we go to question 10. They say to us, D, E, F, G, and H are points on the circumference of the circle, and angle G1 is equal to x plus 20 degrees, and the angle H is equal to 2x plus 10 degrees. We are also given that DE is parallel to FG. Now, after reading the statement, as usual, we will go for the technique DRCPT, the Dr. Cape Town technique. D, the diameter, but there is no diameter, we go for R. There is no radius, we go for C, the cyclic quad. Then I find that this is a cyclic quad. Therefore, this angle and this angle are supplementary. Why? Because they are the opposite angles of this cyclic quad. And this angle and that angle are supplementary because opposite angles of the cyclic quad are supplementary. Now, let us go to the next cyclic quad. I find it to be this one. Now, this angle and that angle are supplementary, and this angle and this angle are supplementary. Reason being, opposite angles of a cyclic quadrilateral are supplementary. Okay. Now we are done with the cyclic quad. We go for P parallel lines. Like we are given that DE here is parallel to FG. Now this angle is equal to that angle as they form the Z shape because those are the alternating angles. Why? Because DE is parallel to FG. Okay, and the angle F is equal to angle D1 right here because those are the alternating angles since DE is parallel to FG. We are done because we can't find their corresponding angles and their co-interior angles. Go to the next letter, which is T here, the tangent, but we don't have any tangent. Therefore, we're not going to talk about any theorem that involves the tangent because there's no tangent in the diagram. Now, we can freely go to the questions and answers, whatever we are required to answer. Now, question 10.1, the size, we are required to find the size of angle GEG in terms of x? DEG. Oh, we said DEG is equal to angle G1. So DEG is going to be equals to x plus 20 degrees, not 26, but 20 degrees. X plus 20 degrees. And then reason being alternating angles are equal. Why? Because DE is parallel to FG. Fine. Done with 10.1, now we go to 10.2. Now we are required to find what is this. Oh, let me, guys, quickly confirm what this is before I can just conclude about this thing. Can I just quickly confirm what it is? What is written there? Is I'm still confirming that because it seems to be a little bit blurry this side. So it is okay. What is this question? Oh, there we go. It is DHG. Is it DHE? Yes, it is DHE. So now this is DHE. Calculate the size of angle DHE. Who is DHE? DHE is this one. And we said this is a cyclic quad. We said this is a cyclic quad. Therefore, we said this angle and this angle are supplementary. Therefore, to find the size of DHE, which is DHE. Wait, I'm sorry. Oh, DHG, not E. DHG. 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 The size of DHE here now. Meaning we first need to calculate the value of x. And then we're going to substitute it here and simplify this thing. Now, remember we had that angle as x plus 20 degrees. So now what are we going to do? We are going to say angle E plus that angle DHG is equals to 180 degrees. Then reason being opposite angles of a cyclic quad are supplementary, right? What is E? E is x plus 20 degrees. DHG is 2x plus 10. Then that is equals to 180 degrees. X plus 2x gives me 3x is equals to 180 degrees minus this 10 degrees minus that 20 degrees. It gives me 150 degrees. I divide by 3 on the both sides. I get x is equal to 150 divided by 3, I get 50 degrees. So this is the value of x. This is not the value of DHG. Now, DHG is equals to 2x plus 10 degrees, right? Now, what are we going to do next? We're going to substitute the value of x on x there. 2 times x, or is x? X is 50 plus 10. 2 times 50 gives me 100 degrees plus 10 degrees. Then I get 110 degrees. Then you are done finding the size of the HG. Now, we can go to the next question, guys, which is this one. Now, this question says to us, O is the center of the circle PTR, right? PTR with the center O, right? Now, N is the point on the chord RP, right? Where is RP? RP is the chord, N is there, right? Such that ON is perpendicular to RP. Now, this is theorem 1. A line drawn from the center that is perpendicular to that chord bisects the chord. Therefore, Rn here is equal to NP. Now, RS and PS are the tangent. PS and RS to the circle at R and P respectively. What does respectively mean? This goes with this, and this goes with this accordingly. Okay, correspondingly, you can say it like that. Now, RS is 15 units. RS is 15 units. TS here. It is 9 units. RPS. Now, and the RPS is 42.383 units. I mean, oh, I'm sorry. I don't know why I keep on messing with this. It is 42.83 degrees, not units. 42.83 degrees. Now, let us do our analysis using the technique PRCPT. The diameter, we don't have any diameter, but we have the radius. Now, this is the radius, that is also a radius, therefore this will be equal to this. And Pythagoras theorem is applicable on the triangle ONR, right? Yes. We can go for the C cyclic quad. You don't have any cyclic quad. You don't have any parallel lines. But we have a tangent. Now, a radius is perpendicular to the tangent. Now we have a 90 degrees here. We also have a 90 degrees here. Reason being, a radius is perpendicular to the tangent. Now, 11.1 says to us we have to calculate the size of angle NOR. NOR. Now, how are we going to calculate the size of that angle NOR? Now, remember that theorem where we have two tangents like this, and they move from the same point. These are tangents. The length of this tangent will be the same as the length of this tangent. Actually, not the length as such, but the distance from the point of intersection of the tangent to the point of contact of the tangent and the second is the same as the length of the other tangent from the point of contact to the point of contact of the tangent in the circle. I hope that makes sense. So SP is equals to RS. Reason being tangent from the same point. Tangent from the same point. Okay. Now the next thing, PRS is equal to 42.83. Right? PRS. PRS is equal to this, is equal to that angle. Why? Because now this triangle is an isosceles triangle because these lines are equal. Therefore, SRP is equals to 42.83 degrees. You can say base of an isosceles triangle or angle opposite equal sides, right? Yeah. Now we can have ORS. ORS. This one. We mentioned that this is 90 degrees. ORS, the at R is equals to 90 degrees. Why? Because tangent is perpendicular to a radius. Now we want NOR. NOR. Okay. Now we will have to find this angle here, right? How? We have this one. We will say 90 minus this one. So we're going to say that angle ORN is equals to 90 degrees minus 42.83 degrees. And I get 90 minus 42.83, I get 47.17. 47.17 degrees, right? For this part. Now, we are having this angle as that one, A1 NOR. We can use interior angles of a triangle. Now, this angle will be equal to 180 degrees minus this 90 degrees minus this 47.17 degrees. That is equal to 180 degrees minus 90 minus that other angle. I get 42.83 degrees. The reason being interior angles of a triangle are supplementary. Thank you. We go to the next one, 11.2, requiring us to find the length of the radius of this circle. Now, how are we going to find the length of this the length of the radius? Now, we can use the two options. The first one is to let OR be x, which is the radius of this circle, be x, right? We let it to x. Now, OS is going to be x plus 9, right? Because remember, this is the radius. So it will be x plus this 9 here, right? Now you will say, okay, we said we let OR to be x. Now, OS will be x plus 9, right? ORS is equal to 90 degrees. ORS, we know that. ORS is equals to 90 degrees. We said the reason is tangent is perpendicular to the radius. All right? Yes. Now, what are we going to do? We are going to use the Pythagoras theorem. We are having the right angled triangle here. Now, we can just simply say OS squared is equals to OR squared plus RS squared. What is the reason behind that? Pythagoras theorem. Now, what is OS? OS is x plus 9 squared is equals to OR squared. It is x squared. RS is equals to 15. RS here is RS. So it's going to be 15 squared. Now, simplifying the left-hand side, I'm having x plus 9 squared, which is going to be x plus 9 times x plus 9 is equals to x squared plus 15 squared. Now, I can just quickly simplify 15 squared gives me 225. 225. Now x times x squared, x times 9 gives me 9x, 9 times x gives me 9x plus 9 times 9, it is 81, is equals to x squared plus 225. Simplification of the left-hand side gives me x squared plus 18x plus 81 is equals to x squared plus 225. Now taking everything to the left-hand side, I get x squared minus x squared. This x squared minus that x squared, I have plus 18x and 81 minus 225. I get minus 144, right? Yes. Now, what am I going to do? I'm going to say this is equals to 0. This cancels out with that. I have 18x is equals to, I take back 144. I divide by 18 on the both sides. Now, x is equals to 144 divided by 18 gives me 8. Therefore, x is equal to 8. We said x is OR. Therefore, OR is the radius of this circle. Now, you will simply say the radius of the circle is equals to 8 units. By doing that, you are now done answering the questions you were required to ask. Now, we will end here for this lesson. For the next one, we will start proving this theorem. Now, this theorem, they say to you, use the diagram below to prove the theorem which states that angle EFG is this angle here, right? Now, it is equals to EDF. EDF is this angle. So now with this one, you are required to prove the tan chord theorem that says that the angle that is between the tangent and the chord, which is exactly this one, it is equals to the angle that is right opposite this chord that we just talked about inside this triangle. And how the tan chord theorem works, you need to be sure that all the three vertices of the triangle are on the circumference of the second chord. Sometimes people confuse this tan chord theorem with something that can be like this. There's a difference between the two diagrams. You can't say here this angle is equals to that angle. Why? Because now, when you notice this triangle, 1, 2, only these two vertices of this blue triangle are on the circumference, and the third vertex of the triangle is roaming around inside the circle, not on the circumference. So, in order for the tan chord theorem to be applicable, all three vertices of the triangle needs to be on the circumference of the circle. So, in the next lesson, we will start by first proving how tan chord theorem became applicable. Why do we say this angle is equal to this angle? And then we will continue with the rest of the following problems. Otherwise, I hope you guys enjoyed this lesson. I will see you guys in the next one.